welcome back, everyone, to our last day and last round of Blister Summit panel sessions. It's probably fair to say that I'm particularly proud of this panel session because a whole lot of work has gone into this so far, and we're just really proud with what has already happened with this new program you may have heard of called BLISTER Labs. So that is what we're going to be talking about here tonight. But before we get there, I thought we should probably raise our glasses. This has been an incredible 3 days, and it's been so much fun. I had at least 5 people over the last 3 days say that whether it was day 1 and then day 2 and then it repeated again today, this was their favorite ski day in their entire life. We've had multiple people tell some of our folks that actually yesterday or today was the best day of their life. So I think that's pretty good. So it's been so much fun, and so I raise my glass to all of you. Thank you for being a part of this. Yeah, amazing.
Thank you, Jonathan.
So, BLISTER Labs. Some of you maybe saw a brief video that we posted about BLISTER Labs and this partnership that has developed between Blister and the CU Boulder Engineering program and the program at Western Colorado University, where we have access to an absolutely state-of-the-art engineering facility that is quite incredible. A big part of BLISTER Labs are these 4 individuals that you see here. And so we are going to, what I really wanted to do, because I love all 4 of these people, is have a chance to introduce them to you, have you learn a bit more about them, and then we're going to start talking a bit more about some of the goals, aims, and particular projects that we're already working on with the labs. So why don't we go down the line here, and I'll start with Jeni, and tell us a bit about, well, let's do this. Tell us a bit about your academic background and just some of the areas of engineering that you are kind of currently working in, and we'll start there.
Start down the line. All right. Hopefully this isn't too boring and we can keep it interesting. But Jeni Blacklock, so officially the director of the partnership program between Western Colorado University and CU Boulder, where we do have 2 degree programs in mechanical engineering and computer science, and students graduate with CU Boulder degree programs here in Gunnison. So they're here the whole 4 years as kind of the the overview of that partnership. Now, my academic background, I was born and raised outside Detroit, Michigan, and grew up pretty much with an automotive family or being around automotive industry. My undergrad was in manufacturing engineering. I also had a management degree as well and started right out of undergrad as a project manager designing assembly lines. So my expertise from, probably 16 or whenever, well, I guess a little later than that, but 17 to 21 was in manufacturing, various length scales, did a lot of robotics, some autonomous systems as well. And then I started kind of diving into biomedical world and took some grad classes over there at Wayne State University, which was the local university in Detroit. Started getting interested in the human body, how things worked, but then kind of shrunk down my manufacturing knowledge to nanoparticles and manufacturing, and did a lot of materials research. And so I'm trying to link this all together again. You're like, why do I care about nanoparticle research? But really what it comes down to is the materials and how we can manufacture different materials and how we can work with different materials and how those come into play when we talk about design for manufacturing and manufacturing systems. So then, after completing a master's, I actually had a Fulbright to go over to Germany and continue working on engineering designs, and lived in Berlin for almost 5 years, and just was taking really crazy scientist ideas and applying them to the real world. So, new materials that were coming out, new research that was coming out, and was making them applicable to the real world, but then also talking about the length scales of manufacturing and what that looked like. Outside of when I graduated, went to NIST, was at the National Institute of Standards and Technology. I was a materials researcher there for a while, also focused on manufacturing. And then I went to Mines, Colorado School of Mines. I was assistant department head there for several years. Continued to research advanced manufacturing techniques, have several grants related to advanced manufacturing, and a lot of 3D printing and titanium 3D printing and layer by layer deposition. Ended up at this partnership program. CU Boulder recruited me, I guess now almost 2 years ago, to start this partnership. And, still thinking about and working with manufacturing and design for manufacturing and advanced manufacturing technologies. That's where I'm at now. So I'll let Sean take the the next one.
Also, just before Sean goes, if Jeni's voice sounds familiar, we did record a Gear 30 podcast where we talked about Blister Labs. And so we've done one episode here, and all three of the next people will be making their appearances on Gear 30 as well. But let's have Sean talk.
Cool. Good evening, everyone. Sean Humbert. I'm a professor of mechanical engineering at CU Boulder. I'm also affiliated with the RADI program here at Western. So my lab does robotics. I kind of focus in two areas. One's autonomy. The other is bio-inspired robotics. On the autonomy side, I won't kill you with a bunch of buzzwords. I'll give you a couple cultural references so you can kind of understand what we do in the lab. So here's the movie Prometheus. It's the precursor to like the Alien series. So they eventually fly to that planet, and they go into the caves there, and they launch some drones, and they use laser, like LiDAR technology, to kind of map that all out. And on the home ship, they see a 3D map getting built up as we do that. So we build drones that do that autonomously. You may have also seen Minority Report with Tom Cruise. So in that movie, at some point, the authorities are looking for his character, and they send a bunch of spider-like things into like buildings to go map out the building and interrogate that. And on their iPads, they see the different humans and things in the building. We also build legged robots to do that. And so the team I led over the last 3 years competed in the DARPA Subterranean Challenge. If you guys don't know what DARPA stuff is, every 5 years they have like a grand challenge just to really push the state of the art. So I led a team from CU here, and we competed with 8 other international teams, came in third place, won $500,000 bucks. But we're the top US team, which is really significant because we beat things like Carnegie Mellon, JPL, Caltech, MIT, my alma mater. So that was just really cool to do all that. So the bio-inspired stuff we do is really fun. We study insects. They're just amazing, like little birds, reptiles, cockroaches, anything you can see. They're so agile and so good at what they do, right? If you take a look at like a small bird, it can fly through a bush at like 30 miles an hour with not even like blinking, right? So we can't build robots to do that. So we study those biological organisms, try to distill the principles they're using and the sensory and the feedback architectures they're using to kind of do all this stuff. And then we translate that into robots. And so we do a lot of stuff like that. Now, that's kind of what my lab does right now. On the way, I actually had some experience that's very relevant to what we're doing here in the ski industry. So I spent a couple years between my master's and PhD at Pratt & Whitney Space Propulsion. So I was the project engineer on all of the avionics for the upper stage engines. That's the second stage engine. And I was also the lead structural dynamicist on that project. So I spent a whole summer in Huntsville, Alabama, doing all the modeling and all the structural analysis and doing all the axial lateral vibe testing and acoustic vibe testing on that rocket engine, just to make sure it was good to go to send like $150 million satellites into orbit. And those are the kind of tools and things we're going to be bringing to the BLISTER Labs sort of partnership here. So with that, I'll hand it off to Lauren.
Basically, all I really heard Sean say was, "Hi, my name is Sean. I'm basically Tom Cruise." So, I don't know.
Rocket ships.
If Tom Cruise built rocket ships, that's basically what I heard.
Good combination.
How do you go after that?
Yeah, I'm really not going to. I'm Lauren Cooper. Dr. Lauren Cooper, but I go by Lauren. I don't really like drop the doctor. Never use it. But I just started at the partnership program. This is my first semester, so I'm just moved to Gunnison December 18th. I'm really happy to be here. Just started skiing at Crested Butte. Came from Cal Poly in San Luis Obispo, so I was in the mechanical engineering department there for 4 years. And I think what I want to talk about is more my background with students and my kind of experience teaching. So I have been teaching for, this is about my 12th year teaching. I started in a middle school classroom, in a 7th grade classroom, and thought I would never, ever, ever become a teacher, but that year taught me a lot about teaching. I love teaching. My new students are here. It's so great to see them. But I did my PhD in mechanical engineering, but did a focus on project-based learning and student motivation. So how to keep students engaged in projects, what types of projects will excite students, how to manage industry relationships. So I think that's going to be an expertise that I bring to this partnership with Blister. I also really like statistics and data analysis. So I have some statistics here that we might get to if I'm permitted to get sciencey. But I'm getting to teach a statistics course here, and I'm really excited about bringing data analysis and statistics and my love of it to our partnership with Blister when we start doing gear testing and how to report about data and how to explain data in a way that's interesting to consumers and to customers. Oh, yeah.
Awesome.
Yeah, that's all I'm gonna do.
Greg Vanderbeek. I'm also part of the CU Mechanical Engineering Department. So my background, I guess, is a little more, my path is a little more sinusoidal than some of the other folks. I started out at Mines doing my grad work on environmental engineering, and I was building large-scale remediation systems. So Alaska, California, beautiful places like New Jersey, anywhere there was large spills, and some of these were miles long. I loved the challenge of trying to figure out how are we going to capture, how are we going to contain these, and then how are we going to ultimately get this area back to something that meets all EPA standards. Did that for about 8 years, and as I got higher up in the company, I found that I was doing less like design and implementing and all of that, and I was doing more getting the next project, meeting with clients, meeting with the EPA, which is all excellent skill sets, but not the original reason I got into engineering, which is that I love to problem solve, build, and do all of that. And so, like most environmental engineers, I was building motorcycles in my garage and started my first company. I think you have to make money to have a company, right? At least in, So at that time, a buddy was coming over and was like, what is all this gear? What is all this equipment? And so I started talking to a friend who was a mechanical engineer and a machinist by trade from CU Boulder. And we started taking night classes and decided, hey, we want to start our own company. So we started a custom design and fabrication company specializing in all types of metals in Boulder, Colorado. Did that for about 12 years. And when my first son came along, realized that the small business environment, which is excellent, is not necessarily super forgiving to the family lifestyle. So there was an opening at CU Boulder as a lecturer position, and it was for component design, which is a class I still teach now and I love, and then running some senior design teams. And one of the senior design teams was tasked by Ceramic Speed, who does a lot of bike components, was tasked to create the most efficient drivetrain on the planet. So they said, hey, we think that chains are obsolete and we want to have a better drivetrain. So I look at my 5 eager students, all of them, great bikers, thinking, yeah, this is going to be super simple. It's only been around for 100 years and nobody's changed it. It's probably a reason. So we dove into that and we ended up coming up with a patented shaft drive roller pinion design that we received patents and 6 international patents with it. Ceramic Speed spun off a company and is now doing driven technology, working with Canyon, Specialized, and they're now trying to bring this out to the market. And so that's when I was really hooked on teaching as a profession and just how awesome it is. So you'll probably pick up that I get pretty excited about some of these topics. But yeah, so from that point on, it was no looking back, and went to Colorado School of Mines for 4 years to help develop their hands-on classes, and then got pulled back into the CU world, and now I'm here in Gunnison working for CU.
Okay, so I don't know, fairly impressive set of backgrounds, you know, but here's the thing. I'm going to call it, I actually have kind of a healthy skepticism of engineering. Others might call it a deep skepticism of engineering. And one of the things I really appreciate about the conversations that I have had with these four people is that I have continued to drive home that at least for the work that we're going to be producing and then publishing results, it is extremely important, and it is a clear priority of mine that I want to make sure that we are really finding real world applicability in terms of some of the tests that we're going to be talking about here in a second, because I think that, you know, that's kind of been the mission statement of Blister from the beginning. You know, it's not all we do these days, but still trying to put out the most accurate and useful product information, whether it's in ski equipment or mountain biking equipment or running shoe apparel and equipment. That's still a real clear, it's kind of the backbone, I'd say, of what we do. And so in our conversations, there are all these interesting kind of intellectual things that we can come and do, but the team has been quite aligned and okay with but are we sure that we are aligning this with sort of real world applicability, bringing this very interesting world of engineering and making it very relevant to people that happen to be passionate about outdoor activities, right? And for this reason, actually, Lauren is kind of my current favorite of the group because I think she's maybe the most skeptical too. And so we've had some really fun conversations along this line. Don't bail on me, Lauren. But what I want to do is, and this is another thing that's kind of been amazing, is I want to have each of you just talk about a little bit of your own interest in the outdoor space and some of the outdoor activities that you're most excited about and sort of doing all the time. Yeah. So, Jeni?
Yeah. Well, that is one interesting aspect of this group is that we all love the outdoors and we're very passionate about the outdoors. And it's so fun because, we work hard, but we know the importance of playing hard too. And so from my background, when I was in Berlin, Germany, I looked up best places to live in the U.S. I wanted to come back, and Boulder, Colorado came up, and I had never been there. And very quickly learned that the outdoors was very accessible, not as accessible out here, but it was accessible compared to Berlin, and got right into mountain biking. I learned to ski when I was 4. I remember being in a race when I was 5 or something, right? So it was fun to get back on the slopes again, and got really into backcountry skiing, and then started dabbling in Xterra triathlons and did an Ironman, and it was something that always allowed me to, in a way, work harder is to almost play harder, right? And it's such a great balance, and it's so mentally healthy for you and helps with the creativity when you can really get out there and crush as hard as you can, at least. So with that said, I'm an avid biker and skier and backcountry skier, and I was a swimmer. I was an all-American swimmer growing up, so I love cardio. That's why I did Ironman and had fun doing it, except for the blister that was that big on the bottom of my foot. But that's me. And I am fascinated with the outdoor industry. I buy expensive bikes. I buy expensive skis. I would like to, learn a little bit more about what I'm purchasing and, why things perform how they do, right? So from a personal interest, I'm, very curious about all this. So,
Sean?
Cool. Yeah. So I grew up in Lake Tahoe, West Shore, Tahoma area, and my parents threw me on skis when I was about 2.5. I've loved everything outdoors ever since, especially skiing. It's been a real passion of mine all through my life. Tried to do it as often as possible. The one foray into sort of extreme sports was a Red Bull event. So it was Red Bull Flugtag. I don't know if you guys ever heard about this. So it's a human-powered flying competition. So me and my high school buddies won the first one ever in the U.S., which was in San Francisco. We had like a skateboard with wheels. We had some big bungee cords. We just launched them off this 40-foot pier. I did all the calculations for that. Went around, and then I came back to San Francisco a couple years later, and so I designed like a human catapult. I was the catapultee that time. Flew about 60 feet above that. That's when my frontal lobe wasn't as quite as developed. And I was doing things like that, right? So I think they outlawed a lot of that sort of stuff in Flugtag after that. But so had to go back to like the skiing and things. But so my wife and I moved here about 6 or 7 years ago, just to be and to engage in all the outdoor activity stuff. And I love Crested Butte here, especially the dirt biking and the mountain biking is insane. All the single track and everything out here is just absolutely amazing. So I do want to talk about my blister experience too later. So we'll get back to that. So I'll hand it off to Lauren.
I didn't know this until yesterday, but Sean and I grew up kind of close to each other. I'm from Reno, the biggest little city in the world. Anyone else from Reno? So excited. No.
Lauren always asks this question, by the way.
So yeah, I grew up skiing Tahoe. I taught myself snowboarding when I was, I think 7th grade, and just really committed to it and did border crossing in college. And actually just got a snowboard for my 40th birthday and have been like getting back on the slopes. I skied for a while, I did telemark for a while, and then I don't know what motivated me, just moving back here, wanted to snowboard again. I haven't always done snow sports, so I was one of our state champion aerial dancers under a different name, probably won't find me, but I did I did aerial dancing for a long time, so a lot of agility, a lot of balance, also love cardio. And I also just like being out in nature simply without a ton of gear. So I mean, I love engineering, and I'm so excited to do all this stuff with outdoor testing, but I also really appreciate just being outside. So when I was 18, I did Outward Bound in the Gore Range, which is pretty close to here, so a month backpacking trip, a 4-day solo, and I draw on that experience all of the time. It taught me a lot about self-resilience. And we didn't have any Gore-Tex shells. I mean, we literally had trash bags for our waterproofness. We didn't get tents. All those things were taken away from us, and we were fine. We were totally fine. So I have that part of me too that appreciates just the simplicity of just being outside.
Greg.
Yes, sports have always been an outlet for me. I got into climbing in my undergrad. I was out in the Midwest, so it was all New River Gorge, Red River Gorge, North Carolina, and knew right away that I wanted to come west. Only applied to grad schools where there's a lot of climbing accessibility. At that time, through my 20s, all I wanted to do was crack climb, big walls. And then I moved in with a group of mountain bikers, and none of them would climb with me. And all they would do is mountain bike. And so I started doing that. And I was like, wow, this is awesome. So I got into mountain biking and haven't really done much climbing since then. I won't bore you with any injuries of the real catalyst for that. But started skiing when I got here. Telemarked for a while until my friends pointed out that I just slowed them down and that I should fix the problem and fix my heel. And so now I'm trying to keep up with other people, but enjoy mountain biking and skiing now that I'm out here the most, yeah.
Kind of selfishly, I want to hear Sean talk about his blister story. I don't know where he's going to go, but our very first meeting, this kind of came up, and I don't know if that's what you were going to share, but I'll share it if you don't.
Okay, no, this is a good intro to kind of what we want to get into anyway. So, as you guys all probably did 10, 15 years ago, when you're going to go buy a new pair of skis, maybe grab a magazine or something and flip to like a gear review thing. And it was some fluff piece written by like a marketer or something, right? So about 5 years ago, I started looking at, I was interested in new backcountry setup. So I ran across the Blister website, and, for once, some of the reviews actually started to speak to me, right, as a skier and somebody who's been doing it for a long time. And so I was just really engaged in the website, really excited with what Jonathan, the place they've taken it. And so, we got the whole Western thing going. I had an opportunity to come out and teach this past semester. And the second I got here, Jeni walks in, she says, hey, do you know what Blister is? We're actually talking to the editor, Jonathan. I'm like, are you kidding me? That's great. They're like, yeah, they want to start doing some more quantitative analysis of gear and stuff. And again, when I was looking at those reviews, I was thinking that, and I'm like, you know what? I can probably paint that stuff with the right mathematics. and do some additional testing and really dig into some of this stuff. So, and that kind of inspired a lot of the stuff that we're doing. But anyway, so that's kind of my blister story.
So the first time, I remember Jeni called me and was like, can you get down to Western in like an hour? I was like, not really. She's like, just get down here. And this guy, Sean, is here, and we had not met, and like, just get down here. So I do what Jeni tells me to do, and walk into the engineering facility, and Greg actually introduced Sean and me, and I'm going to quote you, Greg. Greg was like, hey, this is Sean Humbert. He's for lack of a better word, Greg just said, he's a total badass in the engineering world. And I was like, wow, Sean, it's great to meet you. And Sean at that point, was like, it's really nice to meet you. I've been following Blister for quite a while. And then Sean showed this slideshow presentation where, he was talking about like the artificial intelligent robot dogs and stuff and like doing all this cool stuff. Well, the 10th slide, as he's showing off all this like incredible work he's done, the 10th slide is a picture of his garage. And there's like 5 pairs of skis. I hope I didn't shortchange you, 5-ish.
At least 10.
Okay, 10. And he's like, he just stopped. He's like, every one of these skis I purchased after reading a Blister review. And I was like, this is pretty cool. He and I might get along all right now. But so anyway, we say all that, I hope, because it is really important to me that as we take this step to, as Sean said, integrate more quantitative testing and analysis into this world, I do feel like we have a pretty good thing going at Blister in terms of what our approach has been and what it's looked like. And it has really mattered to me that these high-level engineers that we're talking to get that, understand that world, are passionate about that world, and that I'm not going to have to be fighting when it comes to like that whole thing about the real world applicability of some of this testing, right? And I'm not worried about that right now. So maybe it's time to just start talking about a few of the different projects, right? When you're starting anything, it's like, well, what's the first step, right? And I think where this goes over the next 2, 3, 4, 5 years, that's going to be something. But I think I want to have us talk a bit about some of the first projects that we have identified after, where we've kind of landed for now, having, probably talked about 30 potential places that we could begin. And so I don't know which of you, maybe we'll have Sean start. Let's talk, and we'll just go through some of the projects now, and then I promise we will open things up as we do here and see what questions you might have for these folks.
Yeah, so I've primarily been focused on the quantitative ski analysis, and again, reading the Blister reviews, just really insightful qualitative analyses of the amazing folks that are reviewing the gear and everything. But again, I think that in looking at that, I really wanted to put some quantification to that. I really wanted to have a plot that I could look at, right? And so, we've started some projects with the amazing students in the back here at Western. So we're building ski rigs. So we're going to, building the whole, bending and torsional stiffness testing. But I want to talk a little bit for a second about where we want to go with that, right? So last night's panel was very eye-opening for me. It was actually jaw-dropping in some places, especially when I think it was the ROSI rep that was talking about, their engineers would bring in a design and say, this is the best thing we can design on the computer. And you go ski on that, and it just skis like crap, right? So having that sort of a disconnect in this industry is just crazy. Now, again, the product and the experience of the user is very different than designing a second stage rocket engine, for instance, right? That's got to work perfectly, and tolerances and all sorts of crazy stuff for all that to happen. But the user experience for a skier is very different, right? It depends on your aggressiveness, right? And your level of tiredness and the snow conditions, all that stuff, right? So I think those are some of the reasons it's been hard to put down some quantitative stuff, right? Now, again, there's a lot of talk last night about the torsional and bending stiffness of skis and things, maybe even adding some damping or maybe even changing the mass distribution a little bit, right? So those are all really important things. One of the things we're going to be innovating and introducing to the whole realm of this is, we can all write down equations. We can go measure properties of skis. For instance, I can take a ski and go, throw it in a finite element analysis and get like the bending and torsional natural frequencies and modes. But if I hand that to somebody that doesn't have an engineering background, right, they don't know what to do with that, right? It sounds like the ROSI folks, those engineers, don't know how to hand that off to anybody either, right? So it's really interesting that there's this huge disconnect. So the one piece that's missing, and you can write down fancy equations, you can go measure properties. The one piece that's missing is real-time, loads that can be applied to the models to actually generate something useful. Okay, so these aren't just static loads you apply at different places. They're not just spatially distributed loads you apply at different places. They're spatiotemporal loads, right? So, if you're talking about bending skis, you're also talking about camber, you're talking about side cut, you're talking about rocker, you're talking about all sorts of stuff, right? Like rocker was a big thing that came into the industry and really revolutionized skis, right? So we want to take these models. We also want to see if there's any other revolutions in there. But having the loads, that's really important. So that's what we're going to be doing. Again, we're not just testing skis in the lab. We're actually instrumenting skis. We're going to be putting accelerometers, strain sensors on these things, hundreds of sensors, going up on the hill, getting some real-world data to back out the loads, and I'll talk about how hard that is in a sec. But it's also really important to understand the need for that data too. So getting that data is very difficult, right? It's actually a really difficult problem. It's an ill-posed problem. I can't just go take a couple measurements and back out spatiotemporal loads, right? You can't do that. But we've figured out ways to do that. I told you I study a lot of biology. This problem was actually very elegantly solved about 250 million years ago. All the insects that you see crawling around, the lizards that are running through rocks and not even thinking about it, they're doing that real time, and our supercomputers can't do it. But that's one of the principles we've transitioned from my lab. So, we're going to go take that data, we're going to be backing out those loads, and we're going to be plugging that through models to be able to generate something that's consumable by somebody who's not an engineer, right? And then the second part of this is also correlating that with all of the great qualitative analysis that all of the reviewers here at Blister are doing, right? So when you say a ski holds an edge really well at speed, like I want to have something that you all can look at and say, oh, that's great, right? And again, the whole point, and this is just to bring it back to Jonathan's initial point, the whole point here is not to have rankings of different skis or things like that. It's really to get the user, which is the skier, into the right gear to maximize their experience, right? And as we talked about in the panel last night, it's not just there's one ski and one equation and one way to do this, right? Like it depends, again, on your ski level and your aggressiveness and your style, all of that stuff has to go into this, right? So again, I think we can start doing some slices and through this big cross-section of variables to start generating some useful stuff for everyone. So anyway, that's kind of where we're going with the ski. We're going to apply the same type of stuff to mountain bikes and other things and gear, but so we have so many ways and so many directions to go with this, right? But right now, it's for the rest of this semester, we've got the folks down at Western building all sorts of cool rigs and testing rigs for us and everything. But we're going to be instrumenting skis, and again, using that bio-inspired principle I was telling you guys about. So actually, I build that all into my drones and everything. So we're going to take that hardware and software, transition to the skis, go get that data. So we're going to be able to start doing some cool stuff. So,
Lauren. Hey. No. Wait. Let me go, Lauren. I want to tell the people about what we've been talking about. Because I'm really, the stuff that Sean and Greg and I have been talking about along these lines are really interesting. And one thing I'll maybe just add is it sometimes feels to me that engineering in the real world ends up sort of being a picture of some table that is put on a product, right, that's supposed to tell you this product does this or that. What we're talking about doing, and I keep telling these people, and I'm sorry because it makes me sound mean or something, I keep saying, I can't wait for the fights. I can't wait for the disagreements, right? If we start coming up with certain, analysis from dynamic modeling, and Sean's like, look at this, and we're, say the skiers are like, yeah, that doesn't seem to correlate to our experience on the mountain. I think that's going to make for some of the really interesting conversations. And as someone who isn't a trained engineer, I like in Gear 30 podcasts, that's where we might start having this out. And now, at least again, as the non-engineer, engineering is no longer just the like snapshot of a table that's sort of that's supposed to be the settle the arguments or something. Engineering becomes a process. And I think that we can bring the sort of discipline of engineering into the world of non-engineers in a really compelling way, right? And I think that's a pretty exciting opportunity for the discipline. So anyway, Lauren, what I'm excited about what we've been doing, and I'll have you speak to this, is where we're starting is actually kind of an examination and interrogation of the ways in which certain testing has happened when it comes to technical apparel, right? We have these weird waterproof and breathability ratings. Some of you have probably seen these. I wonder how many of you look at the numbers and think, I know exactly what that means. And so one of the things that Lauren, and I've really enjoyed this so much, maybe because of my own philosophy background, but let's take a look at where did this come from? And I'll be quiet, but Lauren, do you want to say a bit more about this?
Yeah, Jonathan asked me, I don't know, like, how waterproof is your jacket or something? I was like, I don't know. Like, going back to my Outward Bound experience, I'm fine with, like, a plastic bag. I really don't need a Gore-Tex jacket. I'm A-okay. But it interests me that we have these, you know, we spend a lot of money on Gore-Tex jackets or Patagonia jackets, and sometimes I'm wondering if we're just buying things because we just think that we have to buy the best. So like going to these kind of interesting waterproof ratings. So a Gore-Tex Performance Shell has a waterproof rating of 28,000 millimeters per 24 hours. Does anyone know? I didn't know what that meant. Does anyone know what that means? What does that mean? Greg, what does that mean? What does that mean? 28,000 millimeters per 24 hours. Should be $300. More. So it is tested in a lab, and a 28,000 millimeter per 24 hour rating means that your Gore-Tex shell should be able to withstand 28,000 millimeters of water in a 24-hour period. 28,000 millimeters of water is 92 feet of rain. Like, think of all the other problems we'd have. Like 92 feet of rain fell. I don't think we'd be too worried about our Gore-Tex jacket, but it's really expensive. But maybe, like I was looking at some other jackets, Marmot jacket as like their performance shell can withstand in the lab 10,000 millimeters per 24 hours. That's still 32 feet of rain. Like, we're not going to get that. So where I was going with Jonathan is like, why are these tests set up the way they are? Why do jackets like a Gore-Tex shell, why do they have to be so waterproof? And does the average skier, do we need that performance when, and this is, I think, really interesting, when we're going to see a change in the textile industry? Because big companies like Gore-Tex and Patagonia it's really good that they're doing it, but they're going to start manufacturing their materials without a bunch of toxic chemicals. So I'm not going to get too nerdy with it, but like your Gore-Tex jacket, it has a water repellent finish on it that is made with PFCs or perfluorinated chemicals. And these are the same things that are in like your Teflon pans. And they're bad because they get into the water, they get into the soil, they get into livestock, they get into our bodies. They can pass through breast milk, and they stay around forever. So these big companies are going to start manufacturing, and that they're already starting to make gear without these really harmful chemicals. But I'm wondering if it's going to take some quantification of like, does this environmentally friendly shell still work as good as the old Gore-Tex shell? And did I really need that 28,000 millimeter per 24 hour waterproof rating anyway? So I'm really excited about testing of fabric, seeing if we can set up just like a waterproof test. And kind of putting data out there that might convince people that the environmentally friendly options are still really good options. So yeah, we're going to start with just some basic waterproof testing. There are international standards that exist for how to run these waterproof tests, and it's something that we can rig up at the Rady building, no problem, and see if we get the same sort of results that our jackets and our outer gear are rated for. And then from there, maybe we can come up with tests for breathability, et cetera. But we're just going to start with the waterproofing.
Mm-hmm. All right, I want to open this up to questions quickly. So Greg, this is, we're supposed to be talking about snow sports, but I want to give you like 2 minutes and not more. And I know, sorry. I know, sorry. I know. But we're teasing this, right? This is the opening salvo. The tickler, the teaser. So I'm going to cut you off in 2 minutes, but just talk a little bit about some of the conversations that we've been having outside of the stuff that we've already talked about here, and then we're going to open it up to questions.
Yeah, so we've been talking about testing different parts of mountain bikes, and it's a complex topic, and where we landed was wheel sets. I think that it's the number one upgrade that people make on their bikes, and it's also a pricey one. And so the question gets posed of, what is the right wheel set? Is there a difference performance-wise between a $300, $400 wheel set and $2,500 is easy. Gear is a personalized experience. So one person may like the feel of an incredibly stiff wheel. Somebody else may want something that's more compliant. So we're looking into, and we're going to start with some standardized testing like the UCI drop tests, but then add a lot of dynamics to it. So UCI drop test, you can find that data all over the place. Drop weights on the wheels, and then typically it's for failure. We're gonna be instrumenting it and looking at, okay, well, how much deflection happens? How quickly does the rebound happen? What do the harmonics look like? Once again, always trying to relate this to the feel, right? When we are talking about wheel sets, there's a lot of really amazing adjectives out there you're gonna see in the review. So can those be related to quantifiable metrics that if we can measure in the field and then or in the lab and then verify in the field and align with expert long form reviews, could that give the end user a better decision where it's like, wow, I really liked riding this. This new wheel came out. It seems to be very similar, aligned in properties. I want to try that one.
Question came in, how are you going to press skis? This has been something we've been talking a lot about, right? So.
Yeah, great question. So I think initially we'll have lots of accelerometers on there. So in my lab, we're developing, and also in collaboration with some of the other faculty at CU Boulder, capacitive-based flexible strain gauges that can just be thrown on top. So the initial data collections will all be with just stuff we throw on existing skis, right? So we're not going to be creating or designing or pressing any new skis. We eventually will do stuff like that. So I kind of mentioned the UAVs and the drones we have in my lab. We instrument the arms and the chassis and the airframe of the drones. We embed strain sensors in the drones as we're building that, like 3D printing that. And then we also have signal routing with all those sensors too, right? So we pull all the signals out to like a common like DSP right at the middle, and we can do all the processing and stuff, right? So I think I'd love to eventually get to the point where we're building sensors into skis. I think that'd be amazing. I could talk for an hour about how cool that is. But just initially, we're gonna have flexible, capacitive-based strain gauges coming out of CU Boulder, plus accelerometers instrumented, and those are all going to be routed to like a small like microprocessor or something to collect all the data.
How are we going to relate properties, like if we measure a Gore-Tex shell and it's super waterproof, how are we going to maybe relate that to like the user experience or the comfort level, or like if you have two properties, breathability and waterproof, how might those like work together? I think I'm a mixed methods researcher, so my eye is always on quantitative and qualitative and how do they work together to tell a story. So what Jonathan and I were talking about is, what if you have the most waterproof shell, but like you're sitting on a chairlift and you have a pinch point and water gets in your butt, like, like
water in your butt.
Daily conversations.
Sorry, I'm small children. But yeah, so what I'm really interested in is like, what is the millimeters per 24 hours? What's the threshold that we need to feel comfortable for a certain activity? What if it's not 28,000? What if it's like 5,000? And then what are the ratings for breathability in combination with waterproofness? Like what is comfortable for people? In our location, it would be different if we were skiing on the East Coast where it's more humid. Did that kind of answer it?
Yeah, no, that's exactly it. Like, kind of that combination between who cares?
Yeah, who cares?
Like
Yeah. Yeah. Right. Yeah. Or you could wear like a fishing suit, like a rain suit, but you wouldn't have the breathability. So what's the sweet spot, and what are, like, I think about the Western students, and they're probably, I'm hoping that they are going to be some of the great minds that are solving these challenges with getting these really toxic chemicals out of our wear. So this, for me, is also just building awareness that, I want our students to be aware that there's a different way to design things, but how do you design the tests to verify that what you're designing is meeting the needs of real people?
Yeah, I'm just going to add real quick. And so, I love what Lauren was saying about taking several different measurements and approaches to analysis. And we've been calling it a circular approach. Like, we don't just have like one linear pathway to solving this problem. We're taking it, and it's not even like a million different pathways. We're taking a circular approach, meaning that we're taking all this data and then we're evaluating it, and then we're redoing it and evaluating it, and taking all these different pathways of data analysis into consideration, whether it's usability from users or in situ in lab, however it may be. But taking the circular approach, I think, is a really unique aspect of like what we're doing right now and talking about right now.
So the question is, do we think there's the potential here not only to test existing products, but potentially help in the development of new products?
Yeah, I'll speak a little to that. Initially, I think, current products that are out there that have standards that we could test ours to is a great start. But one of the advantages of being a university is that we are a nonprofit. So we have the ability to collaborate and work with a large array of groups. And so collaboration is kind of at the forefront. So yeah, we would be excited to work with companies, work with sponsors, new ideas. Obviously, being on the forefront of design is really exciting for our students and faculty.
Yeah, so I'll give you one example. I think in the panel, the ski design panel last night, we talked a lot about stiffness profiles and modifying those. We also heard about maybe adding different types of damping at various parts in the ski, maybe even shuffling the mass distribution about a little bit. Once we get these models to the point where they're reasonable and predicting real world things and validated with actual data from the slope, right, we can start to explore that parameter space, right? So we can throw supercomputers at that and really interrogate that design space. And then we could start talking about, well, what does a damping profile look like in the ski? What does a mass profile look like in the ski? You go simulate that and actually start to, but the way we do that now is you just have to design and build the ski and then go test it, right? And that's a long process, right? Where I can do hundreds of thousands of iterations in an evening versus, I don't know how long it takes to build. Sometimes it's a day or two to go build the ski and then do all that stuff. But that's exactly where we want to take this stuff. So thank you for the question.
And I'll add one more little piece to that. So as we're doing all this data analytics and we're doing product testing, like, of course we're going to learn more about products, right? So it's inevitable that we ultimately could have ideas that advance the technology as well. I mean, it's just bound to happen.
And one thing I want to add, and I'm really excited about this too. We've already started doing some of this. Given the work we've been doing at Blister over the last 11 years, and just going down the rabbit hole in terms of the technical details of all of these different products, we just know many of the product designers from many of these companies from all around the world. And one of the things that I think we're in a pretty unique position to be able to do is bring those designers to campus, and we're going to get into conversations with the folks you see here and students and start chopping it up as we start evaluating and reevaluating how certain things are built, how certain things are tested, certain standards. And we've already been doing some of that. And that's a really cool element of this program that I don't think we've really touched on yet. But you'll be seeing and hearing more about some of that going forward. We're going to wrap up, I think, in the next 5 minutes.
Right now, the ski testing, the dynamic rig for ski testing, as well as the mountain bike wheel set testing is being done in a class. So it's a semester-long class. It's a junior level class where they're designing, modeling, and building, and then taking the data and analyzing it. We also have the possibility of doing senior design projects, which the advantage of that is that it's a year-long project, so you can really dive into the material more. So I see a lot of these classes and projects feeding into each other, where one could lead to some great questions that are like, well, we need to continue on with this. Let's turn this into a year-long project with these students.
Like Greg and I are going to we have the same students, and I do data analysis, so that's the class, and you're just going to build some stuff. So we're like, why don't we just make this easier on ourselves and the students and combine it? So the projects that are happening right now, then the students, I can work with them on the instrumentation and gathering the data, and what do you do with data, and how do you tell a good story, et cetera, et cetera. So I think one of the great advantages about having this small new program is that we can have those collaborations, and we're not just going to do our own thing without all talking to each other, and showing our students that projects are holistic. They're not just done in one class and then you forget about it. Like it takes multiple faculty members and maybe more than one semester to do something that's really meaningful.
Mm-hmm. And then, we have some grad students that will be coming down to help out with some projects, and then internship opportunities for students over the summer to continue these projects. We see these as being 12-month long, right? We have semesters and we have a summer, and so the work doesn't stop in the summer, and we have opportunities for students to participate. What else am I missing? I think we have one more. The Outdoor Industry MBA you were saying. Yep, so we've been working with the Outdoor Industry MBA in capstone projects and what those could look like, and how, we take ideas and how they can also be marketed as well, and help with the product development aspect. So there is a joint collaboration there as well. And then finally, some of our engineering students are really interested in the Outdoor Industry MBA, and so we've been helping provide a clear pathway and how to continue this degree in the outdoor industry realm and how to support them as well. So this is very student-centered. I know we've talked a lot about ourselves in the outdoor industry and what our passions are, but it's all really about the students, and this couldn't be possible without their passions as well, and they are all very passionate on the outdoors, and they are very excited about these projects, and it's really opened a lot of doors for them as well, and it's a unique program in that sense, right? Because there's not many student-focused programs like this that are out there.
Yeah, and so just to be clear, so the outdoor industry engineering, so it'd be a 4+1, so bachelor's plus master's. So it doesn't exist right now. We're getting that in the works. We're going to have that eventually in like a year or two. But that'd be a great program for you to send some of your employees, for instance, to. You go learn the techniques we're doing, learn the analysis, and bring it back to your companies and be able to improve the products.
So the question is just in what will this look like in terms of the publication of the data and the testing that we're going to be doing? And I'll take this one. Yeah, the short answer is yes. We're going to be integrating this into the work we're doing on Blister. And this is a really, really important area for me that we've been talking a lot about, is the communication of this. I have sometimes said engineers maybe not present company.
No, oh my God.
But Lauren agrees with me. Sometimes engineers I don't think are the best at communicating this stuff. And again, when we come back to where I've been talking about the real world applicability of this stuff, I promise I am going to be extremely stringent about, is this being communicated in clear ways and not dumbed down? So that is going to be a lot of the work. And sometimes it seems to me that when some engineers out there, they get the results and it's like that's where the work stops. To me, that's where it starts. And how we communicate this in really meaningful ways is a big thing that we're going to start unfolding on Blister, and we'll see what that looks like. But that is a clear priority of all of this.
And it's really about collaboration too. Like the more we talk to people, the more we talk to industry, the more we talk with each other. I think sometimes engineers get so siloed, and I think that's why you have these experiences that you have. But we love collaboration. That's all of us. This is why we have come together to work on this project. It was an IP question. That's where I'm just going to leave it, if that's okay. But that's a great question, and Sean, you might have some experience with this as well. But for CU Boulder, our tech transfer, we do have agreements. So students will sign agreements, we sign agreements, but the great thing about working with CU Boulder is that they've been through this a lot, right? And so we have the resources to work with companies. Like for instance, when Greg was launching the program with Ceramic Speed and coming up with a brand new high efficiency drivetrain, and they got 6 patents. They were able to work together with the company in order to establish the groundwork ahead of time and then go forward with the project. So if it ever came to advancing new technology, we would be working with industry partners, and then we also have the backing of the university with regards to what that process would look like. But that's a great question. It's very complex.
Okay, last question. So the question was, have we seen before this blending of the qualitative analysis with the quantitative analysis? And I may have missed something somewhere, but to my knowledge, no, I've never seen this.
At least it's not consumer facing or people facing or
Yeah,
any facing.
Yeah, so
But someone might be doing
So
that.
this is a good thing to bring up. Some of the testing that some companies may be doing internally might be doing this qualitative and quantitative, but what it seems to us is pretty new here is that this is all going to go to be consumer facing, right? As we're talking about how do we communicate this on Blister, that's a big part of it, and it's why one of the things we think is super unique about this program.
Yeah, and I'll just follow that up. So from the academic side, once this thing got rolling, I just did a deep dive into all the literature. There are some cool folks, up in Toronto doing some. So there are people thinking about this, but nobody's done it, at least not in published works that we typically like journals and things. So
anyway, we are really excited about this. This is new. This will grow. Stay tuned. You're going to be hearing a lot more about this on Blister, but it's been one of the most exciting things I think I've ever been involved with in my life, and I am so fortunate. I really enjoy these people, and I can't believe it, actually. Just how well we all just get along, how passionate we are about this stuff on the engineering side, or when it just comes to skiing and mountain biking, et cetera. And so the ambitions for this are big. I will say that, and now we got a lot of work to do. And I hope we've been able to give you a sense of who some of the folks are that will be doing this and a bit of the vision, and hopefully you're a little bit excited too. So I think we'll end there, but thanks to all of you, and look forward to our next meeting.
thank you, Jonathan, your staff.